finding the last three of them, and I can say second, give me the second one of that. So it gave you the second row from that, or third row, or whatever. So this is what I want you to start noticing about the array member functions. They are not only for like 1 to 100 and stuff, but it's really for the entire system, whether you're dealing with tables or spreadsheets or mem sheets, which we will talk about in a moment. I may not be able to demonstrate it right now, but essentially mem sheets are a different version of spreadsheets without an interface. It doesn't have this interface, but basically you can say an array is a mem sheet. It's like a spreadsheet, but in memory. And you can say that this column has a particular formula and this column has a particular formula. And whenever you assign and set and get values from that mem sheet, it will recalculate itself just like a spreadsheet. But the good thing is it doesn't have an interface like on the screen. So you can have very large spreadsheets like mem sheets, and you can do pretty much all these calculations in the mem sheet and just take the results and you can go on instead of having to worry about, can the document handle so many rows and all that stuff. Just deal with it as a mem sheet or a set of things in memory. It's a spreadsheet in memory. So that's what a mem sheet is. So mem sheets, spreadsheets, arrays, tables, all of these can be looked at as, in a way, as arrays. And because they're all arrays, you can apply the same member functions that we had looked at here. So if you went and looked at, see, each of those matrices or tables or spreadsheets or mem sheets have all of these functions available to them the moment you look at them as an array. So let's take, for example, dollar, right? So if you took these, like let's say last three or something and assign it to P. So P is now this, right? So now you can say P dot dollar X. If you think if it is an X, what is X squared, or it's cube or something. So essentially, so obviously it cannot convert that string to a number, but you can say something like, X plus 1 or something like that. Something like that. So I'm going to add test to all of those. So it basically adds test to every one of them. And you see when I'm moving this cube, it kind of snaps back. And that is the behavior of cubes by default. They're all going to be kind of centered. So if you find yourself, I don't want it to keep snapping back, what you do is when you move it, you press Alt, and then you can move it and place it anywhere you want. So then it kind of frees itself up. And I believe if you press, when you're moving Control Alt, it's going to snap back. So when it's moving, if you press Alt, it's going to stop snapping. And what it really is trying to do is to center itself in this page. So, so if I press Control Alt, then it's going to start snapping back. And if this also, if I start snapping back, the thing is when you try to move the cube, it's going to show you the center and see if this one, it'll kind of highlight if something is going to match with some other cube, just so that you can lay it out better. And with any new cube you start, so essentially they're going to be centered like that, and you can move it and you'll see, it'll kind of show you those blue highlights to show you that it is the center of this cube is matching with the edge or the border of the other one and so forth. So see, like that one. So this means that both of them have the same center. So you can just snap it there and it'll drop to that. So it tries to, so it's saying that this left of this cube is matching with something up there. So it's matching with this cube here. So you have a way of snapping things back there. So back to the array concept. It's very significant that we look at spreadsheets, arrays, tables, mem sheets, all of them as arrays, and which indirectly means that every one of those tabular structures or three-dimensional, whatever number of dimensions it has, it really doesn't matter. Every one of them have all of these different functions available to them. So let's take this one called CALCI, right? So A is equal to so 45 to 50. I'm trying to fill an array with 4 by 3 and fill it with 45 to 50 numbers. Here you can just say go anywhere somewhere else and say I want the elements of A dot CALCI, and it'll basically give you a CALCI with those values into a CALCI. And I believe we can also say table should work, but I haven't. Yeah, basically gives you a table. You can extract it to a cube. So this is a cube of those numbers. So you can see an array can be referred from any table, spreadsheet, memsheet, or array itself, but then you can put them into a table or a CALCI and even read it back. So now this CALCI is called table 2, and so you can go somewhere else and say, hash table 2, and the numbers come back to you, and you can assign it to something else, and so forth. Arrays can be more than 2 dimensions. Obviously, if you had an array, it's a spreadsheet is a 2-dimensional thing, but you could have had something like so this is actually a 3-dimensional thing. So obviously, if you make it into a CALCI, it's not going to look good, but it's going to try. So it's going to be kind of mixed up here because it's got CALCI of CALCIs or something like that. So it's going to be a little bit mixed up there. However, the interesting thing is that if you had to apply, let's say you want to apply the function sign to them, and now it applied sign to every one of these elements that you see here. Didn't matter how many dimensions it had, it still went and did it. So let's say we assign it to B to see how that looks like. So let's say we just say debug. So, and here you can see that A is actually a 2 by 3 by 4 array. But if you apply this now, it's still a 2 by 3 by 4 array of the signed result value. So the idea here is that arrays can be as multidimensional as you want. Spreadsheets and tables, you'll be a little bit more careful because you cannot really visually represent it. Memsheets don't have that limitation, but it still has that spreadsheet functions and stuff that can be embedded into those memsheets as formulae, so it can get a bit complicated. But that's how they all relate to each other.